Hi, welcome back to Engineering Drawing. I'm your Dr. Vasu. Here you can find other interesting subjects as well along with the engineering drawing. Do subscribe the channel and get alerts. Now, let's see the projections of a pentagonal lamina inclined to both the reference planes. Let's take a pentagonal lamina of 40 mm edges. Its edge length is given. Having one of its edge AE in HP. It has something in the horizontal plane, and this edge is at 45 degrees angle to VP. It's a surface making an angle 30 with HP. So let's take the plane here initially in the horizontal plane, right? And it's a surface making 30 degrees angle with HP, and this edge here is making a 45 degrees angle to the VP. So this is the final position of the pentagonal lamina, and we see the plane like this in the final position. Let's draw the projections now. So initially we have to take the plane in the horizontal plane like this. That is, we have one of its edge AE in the HP. That's why we have to take the plane in the horizontal plane, and it's a surface making angle with HP. That's why the plane must be taken in the horizontal plane. Okay. So draw the plane here like this. Pentagon is drawn such that one edge AE is perpendicular to the reference line because we want this edge AE in the horizontal plane and is making some angle with VP. So here, let's take this AE perpendicular to the reference line. Now, mark all the corner points A, B, C, D, E. Now draw the front view, draw projectors, and here the front view is drawn. Front view points are marked. And now let's reproduce this plane here, which is appearing as a line in the front view, is taken at a 30 degrees angle to HP. Because we want the horizontal edge AE is in the HP, we take this AE on the reference line, and that means we lift the plane like this upwards. So AE is taken here like this, and it is at a 30 degrees angle now. Now let's draw the top view here by drawing the projectors from all the points and horizontal points from horizontal lines from these points. Mark the intersection points here, A, B, C, D, E, and these points are marked here, joined by straight lines. We get the top view. Now, let's reproduce the same top view here such that this AE edge is at 45 degrees angle to the VP. So this AE is at 45 degrees angle to VP. Draw a line here at 45 degrees angle and take this AE edge on this line. Okay, so the AE is taken on this 45 degrees line, and this same figure is redrawn here. By taking this AE as reference points, all the other points are marked, and we reproduce the same, this top view here in a different position. Now, after drawing this top view, let's draw its front view. Draw projectors from all these points and horizontal lines from these points here. Mark the intersection points, you get the A, B, C, D, E, all the intersection points here in the front view. Join them by straight lines, we get the front view. So this is the final front view, final top view, final projections of the plane lamina when it's a surface making angle with both the planes. Next, let's take a pentagonal lamina again, having 40 mm edges. Having one of its edges AB at a 30 degrees angle to HP, and its surface is making an angle 30 degrees to VP. Its surface is making an angle 30 to VP. That's why the plane is taken parallel to VP here, right? And one of its edge AB is at a 30 degrees angle to HP. Okay. Its surface angle inclination is shown here, 30 degrees angle to VP. And this edge here, we may call it as AB. AB is at 30 degrees angle to this AB is at 30 degrees angle to HP, like this. So this is the final position of the plane surface, and the plane appears like this in the front view and in the top view here, right? When you see the plane surface. But now let's draw the projections of this pentagonal lamina. Take the reference line. Now in the front view, we draw the pentagon because its surface is making angle with VP. So the pentagon is constructed here like this. And how? Whether you have to take this edge perpendicular to the reference line or parallel to the reference line. That is the question. Here, we want this one edge, say AB. We will call this as AB. AB is at 30 degrees angle to HP. Because we want to make an angle 30 degrees with the horizontal plane, we have to take this line, this edge, perpendicular to the reference line. That means it will be now parallel to the VP. Then only we can show that 30 degrees angle to the HP. When its line is parallel to the VP, we can see the actual inclination with the HP in the front view. That's why we take this edge AE, say AB, perpendicular to the reference line. Now, complete this, show the dimensioning, mark the intersection, mark the corner points, A, B, C, D, E in the front view, draw projectors onto the top view. Now, draw the top view here. The top view is a line because the plane is taken parallel to VP. It appears like a plane, a line in the top view. Mark the points here in the top view, A, B, C, D. Here AB is named here like this. This vertical edge is named AB because we want to show this edge AB at 30 degrees angle to HP. Let's show the surface inclination first. Even though in this problem, even though this edge angle is given first, after that the surface inclination is given. But don't think that because it is given first, we have to show that first. We have to first of all show the surface angle only first. Then only the other conditions can be satisfied. So first show the surface inclination. That is, in the top view, we can see that angle. So this line should be taken at 30 degrees angle to VP or the reference line like this. So draw a line here at 30 degrees angle and reproduce the same top view here, same length, and mark the points here, A, B, C, D, E. So all the points are marked. Now we have to draw the front view. Draw projectors from all the points and draw horizontal lines from these points. We get the intersection points here, A, B, C, D, E. Now join them by straight lines. We get the front view here. Now, we have to take this, we have to show that this edge AB at 30 degrees angle to the horizontal plane. This edge is now parallel to VP. You can see that in the top view. It is a point, single point in the top view. That means AB is parallel to VP. Now, draw a line here at, that means the pentagon in the front view will be rotated like this. So the AB edge will be taken at a 30 degrees angle to the horizontal plane. So the plane should be rotated like this. Now let's see how to draw. Take a line at a 30 degrees angle, okay, and reproduce the same top view here such that you get AB edge, this edge here on this line. Take two reference points, okay, A here and B here, mark it AB. With this, the same distance is marked. So with these two reference points, get all the remaining 3 points. So with the distances here, AC distance, BC distance, we draw 2 arcs. Similarly, with the AD and BD distances, we have drawn these 2 arcs, that is D. Similarly, E also. Like this, we get all the points in the front view. Join them by straight lines. We get the front view. Now we have to draw the top view here. The top view. To get the top view, draw projectors from all the points and draw horizontal lines from these points here and get the intersection points. Mark them, A, B, C, D, E. Join all the points by straight lines. We get the top view. So here, this is the final front view and final top view. Final projections of the plane lamina. Its surface making angle with both the planes. Now, let's take another one. A pentagonal lamina of 40 mm sides is resting on the corner in HP here. Its surface angle is 30 degrees. Okay. And the edge AE, that is opposite to the corner on which it rests on HP, is making 45 degrees angle with VP. Let us see how to show this. So first of all, take the plane in the horizontal plane here, okay, having one of its edge perpendicular to VP, okay, perpendicular to the reference line here, and show the surface inclination 30 degrees with HP, surface angle 30 degrees with HP, and this corner here, this side we have a corner. The corner is lying on the horizontal plane. So next, take this edge here at a 45 degrees angle to the VP. These are the final projections of the plane lamina. Now, let's draw these projections. Let's show how to draw these projections. Now, take the reference line and draw the top view here such that the one of its edge is perpendicular to the reference line, because we want its edge AE is making an angle 45 degrees with VP. That's why we have taken this perpendicular to the reference line. Why we have to take the plane in the top view? The pentagon is drawn in the top view because the plane is taken parallel to HP, because its surface is making an angle 30 with the HP. Now, let's complete this top view, show the dimensioning. Now let's draw the front view from this. Draw projectors, okay, and complete the front view here, get the front view, mark the points in the front view. This is the first position. Next, in the second position, it's a surface making a 30 degrees angle to HP. And that means we can lift the plane here, this side or this side. We can get on any side, but here it is resting on the corner C. The corner C is in the horizontal plane. That's why we cannot lift this upwards. We have to lift this up such that the corner C will be in the horizontal plane. So lift the plane like this and show 30 degrees angle to HP, 30 degrees to HP. And now mark the front view points. We shall get the top view here. Draw projectors from all these points here and draw horizontal lines from these points. These points are, my intersection points are marked here as A, B, C, D, E. Join them by straight lines. We get the A, B, C, D, E, the top view. Now, here you will see the edge AE. The edge AE is parallel to HP here, because in the front view it is seen like as a single point. That means in the front view, if you see it, it's appearing like a point, and in the top view it is perpendicular to the reference line. So this edge AE is parallel to HP. Opposite to the corner on which it is resting on HP. Actually, this sentence is not necessary, but to understand that even sometimes the problem can be given like this also. The point C is lying on HP. That's it. Opposite to this corner, we have AE. AE is making 45 degrees angle to VP is enough. But to understand further, it is given, or it can be sometimes given like this also. That is, opposite to the corner, that is C dash, on which it is resting on HP. What is that edge? AE. So AE is, this is the AE edge, is making an angle 45 with VP. So we'll take this AE at 45 degrees angle to the reference line. So draw a line here at 45 degrees angle and mark this AE here on this. AE is marked on this 45 degrees line and reproduce the same figure here by taking, of course, take the arcs, the distance of AB, EB, like that. A with A as center one arc, E as center another arc, like you get a point B. Like that, you get all the points here. We finalized the top view here. Now, let's draw the front view. How? Draw projectors from all the points here. Draw horizontal lines from these points. The intersection points are marked here as A, B, C, D, E. Join them by straight lines. We get the front view. So these are the final projections of the pentagonal lamina in this position. Okay. So these are the final projections. So like this, we'll be drawing. We have to analyze at each stage how to take the first initial position, and from there how to get the second position and third, like that. Okay. Hope you had understood this topic very well. And if you have any queries or doubts, please do comment, like, share, and subscribe. Thank you.